graphs of the tangent, cotangent, cosecant, and secant functions. Chapter 6, Section 5. So we already talked about sine and cosine, and those are pretty straightforward and related very well. Now we're going to talk about the other four trigonometric functions, and you'll see that they relate, but they're a little different than sine and cosine. We would not call either one of these sinusoidal waves. So let's take a look at them. So first, the graph of y equals tangent x. I know this is showing a lot of stuff here, but basically what we're seeing is that at negative pi over 2, there is a vertical asymptote, and at pi over 2, there is a vertical asymptote. It passes through the origin. And in between negative pi over 2 and pi over 2, it starts at negative infinity and goes to positive infinity. And we see here also that that's a period of pi. Okay, so this kind of shows what it looks like and gives us some values to look at. We won't go nearly as in depth as this when we have to draw these functions. So let's look at the properties of tangent. So first of all, the domain is the set of all real numbers except odd multiples of pi over 2. Because every pi over 2, you're going to have that vertical asymptote. The range is the set of all real numbers from negative infinity to positive infinity. And it hits that every pi over 2, right? The tangent function is an odd function symmetric with respect to the origin. Tangent function is periodic with a period of pi. Okay, that is the period. Remember, there's the fundamental period. That's the smallest input range that will cover one full cycle. Now, that is the period, but when we start to graph these, I'll show you that it's actually easier to graph them if we treat them as a period of 2 pi, which is valid, but pi is the fundamental period. The x-intercepts are negative 2 pi, negative pi, 0 pi, 2 pi, and every pi before and after that. Y-intercept is 0. Vertical asymptotes occur at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, right? So cycling through there. So let's look at the graph of y equal cotangent x. Well, you see this is somewhat similar, but it seems to work the other direction, right? Also, we notice that the asymptotes are at 0, negative pi, positive pi, right? So every pi, we get an asymptote. Properties of the cotangent function, f of x equal to cotangent x. The domain is the set of all real numbers except multiples of pi. Range is the set of all real numbers. Cotangent function is an odd function, symmetric with respect to the origin. Now notice it didn't pass through the origin, but it was symmetric with respect to the origin. Cotangent function is periodic with a period of pi. Remember, that's the fundamental period. As I said with tangent, it's actually easiest to work with it if we do it as 2 pi. The x-intercepts are at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. There is no y-intercept. Vertical asymptotes occur at negative 2 pi, negative pi, 0 pi, and 2 pi. Okay, on to cosecant and secant. So the graph of y is equal to cosecant x and the graph of y is equal to secant x. Now, you notice that on these, what's shown in orange is the sine function or the cosine function in each of these graphs. And remember that cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Well, once we think of that, it starts to make sense. Anywhere that sine is equal to 0, cosecant has to be undefined because we end up dividing by 0 and we can't do that. So you notice that anywhere that the sine function crosses the x-axis, there are vertical asymptotes. And the same with cosine and secant, since they're reciprocal functions, anytime cosine crosses the x-axis, there are vertical asymptotes. Also, remember that sine goes from -1 to +1. Well, obviously the reciprocal of 1 is 1. But if we take the reciprocal of any value between -1 and +1, then we're going to get a number larger than 1 or greater in magnitude than -1. So we end up with these U-shaped things. So basically, the way I look at it as the easy way to graph the cosecant function or the secant function is graph the sine function or cosine function respectively, and then put the vertical asymptotes in place wherever the function gives you 0, and then just draw these little U-shaped shapes coming off of the sine function above or below. Now notice, please notice that there is space in between. You're going to be above when sine was positive. You're going to be negative when sine is negative. So you will not have a U followed by another U followed by another U. You will have a right side up U. The next section will have an upside down U. The next section will have a right side up U. The next section will have an upside down U. I bring that up because it's a very common mistake to see people just go haywire and put everywhere the U shapes going up and the U shapes going down. Okay, so let's put some of this to work and graph y is equal to the tangent of 1/4 x. Now, this gets treated very similar to what we do with sine and cosine. So we're looking at this, and first of all, the amplitude is 1, but when you're dealing with tangent and cotangent, the amplitude doesn't really mean much. All it's going to do is make it a little, it's going to stretch it. So it's going to increase and reach infinity faster. So if you're being really finicky about all the different points, then you could do it like that original tangent graph that I showed you where it had all these different points plotted. I'm not so concerned about that. I just want to see the basic shape. So having an amplitude of 1 really doesn't have much effect on me. But we do see that omega is equal to 1/4. Now remember I said that I like to deal with 2 pi for the period, even though the fundamental period is just pi. Well, that works nicely because I can use that in the same formula to find the period. The period's going to be 2 pi divided by omega. 2 pi divided by 1/4 is 8 pi. So 8 pi is going to be my endpoint. Halfway in between that and 0 is 4 pi. Half of that is 2 pi. And then halfway between 4 pi and 8 pi is 6 pi. Okay, so I've now put this in place, but what I need to remember as I do this is that tangent is going to go through 2 full periods in this time. So I have to remember that tangent starts at 0. And then at 2 pi, we're going to have a vertical asymptote. At 4 pi, it's going to pass through 0. At 6 pi, we're going to have a vertical asymptote. And at 8 pi, it's going to pass through 0. Then when I go to draw this, in fact, I'll put my asymptotes in now. I've got to remember that 2 pi was an asymptote and 6 pi was an asymptote. Oh, I already put that in there. There we go. So 6 pi is an asymptote. So now I can start drawing my function. Now, please don't laugh at this. I did this by hand, just like I did with sine and cosine, and it doesn't work quite as nicely when doing this with a mouse on the computer. So from 0 to 2 pi, we know we're increasing towards infinity. At 2 pi, we switch from being positive infinity to negative infinity. So we're going to start at negative infinity, pass through 0 at 4 pi, and then go to positive infinity. And then we're going to start at negative infinity and go to 8 pi. And we can see how this comes together. So I like to do this. It shows a little more of it, and it makes it easier for me to just stick with that function that period is equal to 2 pi over omega. So I need to know where is it going to cross the x-axis, and I need to know where those asymptotes are. Then it's just a matter of going up to infinity, starting at negative infinity, going to positive infinity, starting at negative infinity, etc. So that's our graphing of tangent, cotangent, secant, and cosecant.